Okay, so before the break, we were talking about logical operations, and, or, and not, and then we can combine those into other things, but I had a couple sidetracks there in the first half too, but those three operations, and, or, and not, with true false values are enough to build up an entire mathematical system, Boolean algebra, but it's a math class. There's like other things, you know, in math, there is a well-defined order of operations. We have to do things in a certain order, right? You see them pop up on social media all the time. We'll have a math question, ask people what it is, and all kinds of people will get it wrong because of the order of operations. They miss the order of operations. And in your math class, you were probably taught this, right? PEMDAS, usually some silly little sentence to keep track of it, but if you go check Google, there's a lot more inappropriate and funny sentences that would fit those letters, and frankly, the inappropriate and funny ones are better for the human mind to remember, but they're inappropriate, so they don't have any place in the classroom. But Google is full of them to make it easier to remember. But your math teacher would tell you do the parentheses first, then the exponents, then you multiply and divide from left to right, and add and subtract from left to right. And really, at some point, multiply and divide, you learn those are the same operation, right? Probably when you learn to divide fractions, you approach it as multiply by the reciprocal.
Exactly. Yeah.
That's actually one operation. The human mind can handle more complex things, so we go ahead and separate them. Same thing with add and subtract. Subtract really means add the negative.
You're just moving across the number line at that point.
Yeah, so each one of those is kind of one operation. But to specify a little bit further, what's really going on here is grouping, because parentheses aren't the only thing that does that. Right? If we had a radical symbol, the square root of that, anything underneath of that square root sign needs done before anything around it, right? We have to get that back to a single, everything grouped together, or absolute value. We had a whole bunch of stuff between absolute value signs. We have to find all of that stuff before we can apply it outward to the rest of the stuff. Fraction bars, we want to do everything in the numerator and everything in the denominator before we treat that as division. So anything that groups our numbers together. And exponents, they usually mention that because that's what shows up first, but what it really is unitary operations. Use one number. The things that we only have to feed in one number to do. Like it might look like squaring has two numbers, right? If we took 3 squared, it looks like 2, but really that 2 is our operation. It's not a number. It just tells us how many times to multiply 3, right? So that it looks like 2 numbers, but really there's only one number going in, the number we want squared. Because we have some other ones, like factorials. Those only take in one number. The square root is a single operation. That's why we have to do all the grouping, everything under that radical before we can figure out what the square root of it is. Because we only need one number to actually perform that. And then our other two, that's our binary operations in a particular order. And I'm going to write decreasing in order of decreasing inclusivity, a long word. And what I mean by inclusivity is 5 plus 5 plus 5 is the same thing as 5 3 times, right? So more things are included in that multiply operation than the addition operation. Really, the multiplication is including multiple additions. But those operations take into two particular two numbers, not just one. So we do any grouping we have, then we do the operations that only require one number, and then we do the operations that require two numbers in the order of decreasing inclusivity. The ones that include the most in them get done first. And it's the same thing over here. So our order of operations is really, oops, groupings, then we do unitary stuff, then we do binary stuff in decreasing inclusivity, which well, for our logical operations, especially when programming, we're still going to use parentheses. In most of our languages, things like square brackets and the curly braces that we would use in math class have other meaning. So parentheses, we're stuck with parentheses for grouping. Not all of our languages, like in Lisp, none of those are defined, so we can jump back and forth between them and do groupings with the other symbols, but still kind of our parentheses there. And then for those other operations we looked at earlier, the first one we looked at only required one input, right? The not operation only requires a single input in order to negate it. So that one's a unitary operation. And then our binary, again, decreasing inclusivity. Or another way that you might have heard, something you might have heard. Some people hear this in elementary school, and some people either didn't hear it or didn't pay attention to much later. I remember being in 400 level math classes and people were surprised about it. But it's across the board in math to add the ors I'll just put a comma. Add the ors, multiply the ands. You may have heard that at some point, maybe in a section about keywords when you're learning to work with word problems. Add the ors and multiply the ands, and that is across the board in mathematics. And it follows here. And is more, or our logical operators, and was more inclusive than or. So it gets done first. Then we do the ors. So really it's the same order of operations you're familiar with, but those words you probably learned the order of operations on don't necessarily apply. Oh, and electrical engineers, when they're writing stuff out, they really do use multiply for and addition symbol for or. That way they can write a bunch of complicated stuff very, very quickly. But this sentence that most of us heard at some point, I think the ones that some of us might not have paid attention to it, but that is across the board in mathematics. So it fits really nicely in Boolean algebra, where that's our two operations, and we're trying to remember which one gets done before the other. Multiply the ands and add the ors. So same order of operations, but we have to kind of step back and look at what the order of operations really means in order to do that. So does anybody have any questions about the logical operations? Logic gates? Truth tables, I guess that was the other thing on there.
It all looks good.
Okay, I assume silence means no questions. So let's look at a couple examples. I think I'm gonna do the Python example first today. And then because I want to go ahead and include something that might be useful for some of y'all's final projects in Raptor with graphics. So this condition would apply the same, but it'll we'll see that here in a second. So let's do a Python example first. I'll go ahead and share my screen. I'm going to go to this online IDE I regularly use. Cloud stuff is nice, right? It has the auto save, and it's not on our local machine, so it's just on the internet. All we need to get back to it is another machine that can access the internet. So I'll create a new RPL in Python. Sure, that's probably a good name. So we saw a few things for our simple conditions, right? We could set up some numbers, maybe X's, typing. X's and Y's are for when we're writing by hand. So maybe number 1 is 23 and number 2 is some more complicated math thing, 2 times 37 divided by 15. And we get those values, however we go around getting them. Zoom in, there we go. And then we can check those, right? If number 1 is bigger than number 2, so then we'll print number 1 is bigger. But if not, then we'll just print number 2 is bigger. Number 1 is smaller. That might make it a little easier to distinguish between those two. So kind of what we saw before, just a simple condition. We get that, what is that? That's 63 divided by 15. So we have that, but there's other stuff we could do. We could multiply by 9. I think that'll make it bigger. And get our other result. We can also do Booleans directly. And I'm going to do it in a simple example here, but hopefully what I say will make sense when you get to more complicated things. We could also just have a Boolean, some Boolean data. So I can't think of a name, so I'm just going to call it Boolean data and set it to the value true. And our condition next to the keyword worked because that's something that returns true or false. Right? You can actually print that out. Print number 1 bigger than number 2. We see it actually returns true or false. So we could just have a variable to hold that, which in complicated situations, that can be nice because we might have a whole lot of stuff going on and we'll end up with this really long thing written in the selection portion, our condition. But if we have just some data along the way, we can adjust that elsewhere in the code, and then when we get to the selection structure, it will be in a true or false state. We don't have to do the full thing. So we could just say if that Boolean data, and it's true. Otherwise, print, oh, that's a lie. So a couple options there. You see, instead of a condition returning true, we can just store true directly in some data, which very trivial in this case, but if you had a big complicated situation, hopefully you can kind of visualize how as you go through other lines of code, you can determine whether that's true or false, so that by the time you get to your selection, you already have that stored to a nice little reference value. Or vice versa, if we switch that to false.
Is that how I could have fixed my loop in the Raptor project? By
That would
storing it in
work.
a variable? That would have worked? Okay.
Yeah, there's multiple options. Oh wait, your loop did work.
It did, but it was, did you see, I had a limiting factor on it, which was if you put in the correct number first, like above, but then you didn't go below, it would still run and repeat.
Okay. I did
And
not encounter
without
that when
any-
grading it. I ran it. I was like, oh, cool. He put a loop in there for error handling.
I tried it. There was
And it
still
worked.
like, there was a bug. There was a bug.
Okay.
that I couldn't
So
solve.
this would probably be a better way. You could just set your condition to a Boolean, and then
Yes.
when you have the right thing inside the loop, you set the Boolean.
Okay.
We call that a flag. You would raise the flag to say we're done with the loop.
Exactly. I think like it would not be done. It would keep on looping if I put the wrong number in. I can't remember it. I have to go back and look at it. I'll send you a version update if I can.
Okay. And then we can just do more complicated situations. Like I'll get something from the user. I'll just write X. Let's grab an integer from the user. Give us some input with the prompt, enter an integer. And Y is some hard coded number, let's say 5. Then we can check that. So if X is less than 5, or is less than that Y value, and we do use our keywords, notice they're changing colors here, and or not X less than 0, oh, I need parentheses around that. Why is it not like that? Oh, I forgot and. So notice those multiple conditions like we have. Instead of checking things twice, because could have this condition. Well, with what we saw last week, we'd have that first if statement, and then inside it, we need to check the other one. So if that's true, we also need to know if X is greater than or equal to 0. Then we could print out it's positive and small. An arbitrary sentence there, but just looking at the basic syntax here. So we nest that in there, run that, ask for a number, let's say 8. Oh, there's no result from that because there's no else part. So if that's not true, it doesn't do anything. Then -3, if I enter that, it still doesn't do anything. But if I enter a +3, then we get that result saying, okay, that number works. But instead of nesting the loops there, we can use our logical operators. So if X is less than Y and X is greater than or equal to 0, we'd get the same results. Enter an 8, nothing happens. -6, -2, nothing happens. But when there's something in that range, like a 3, then that line of code runs. So it allows us to combine more complicated situations. And you'll notice where that just came from. An and is like a nested if loop. If the first condition is true, we go into that block then we check another condition inside of there. So we can consolidate some of that by using and. Or this one, oops, less than or greater than or equal to is kind of a complicated thing, but the negation of that, so not greater than or equal to, is the same thing as less than. So hopefully that makes sense, how the negation we can just apply to that. Not less than is the same as greater than or equal to. We can just carry that one right over to the sign. And we can build up more complicated situations that way. Enter an integer, and 8 does nothing. -1 does nothing, but a 3 is in that little range we narrowed down. So we could set up some different conditions. So like if X, the number the user gave us, is bigger than, say, 16, or X is smaller than -16, then I don't know, print outside of I meant to put 15 there, outside of plus minus and 4 bits.
I could see using this to see if like an attack hits.
Yes, yeah, that is for cybersecurity people, this is what you're checking. So enter a number. If we say 32, that's more than we could store in a 4-bit number, right? We can only go from 0 to 15 or 0 to -15. So it's outside of that range, which actually the positive or minus would be 7. I don't know what I was thinking. I needed up that. That would be a 5-bit number. So like we saw, when we have 4 bits and then use one of them for a sign bit, we can only go from -7 to +7. So if our value has to be in a range, we can say, okay, that's outside of the range, enter another number or something like that. Whoops. But how about a valid number? So we could check things like this, and then yeah, for cybersecurity people, you would just run these checks. And if any of them are true, then there's something to worry about, or false, or just kind of depends on the situation. So like a 4 would work. We don't get any result. It's a valid number, so we move on. But a 9 is more than a positive or negative number we could put inside of 4 bits. And yeah, then move on. Probably more descriptive things. But this is just a quick pass at syntax. We learn by doing. So best way to learn is just to make up some examples and kind of run through them and see how it goes. Those are our keywords. So to combine multiple conditions, you need and, not, and or in Python. So for our other one, we can use the words or some symbols. So I'll just bring in I'll set up a couple values. Maybe roll the same one. Enter a number. It's user number. And then we can check and see if user number is less than 5 and not user number greater than 0. Well, less than 0. If it's less than 5 but not less than 0. And notice how there's no abbreviation there. The entire condition had to be spelled out both times. We can't the computer can't infer that we would be talking about user number both times. So over here or when we did it here, we had to put the whole condition on this side of the logical operator and the whole condition on this side of the logical operator. We can't make any inferences or shortcuts on them. All we have is a way to put them together. That's one thing a lot of people try to do at first is they want to abbreviate stuff. I can't remember what the output I did on there was. So like output, if it fits that condition, then that number will work. If it doesn't fit that condition, that number is no good. And we get the same thing we did before. So we input a number, say 8, and get that number is no good, or -2, not a good number, or finally something in that range. Hopefully that all makes sense. It's usually an easy step for people to take after the simple conditions. We can combine conditions. The one thing that most people get off when they first start is they want to imply things. So like both of these conditions refer to user number. So as a human, and when we put that in English, we can say user number is less than 5 and bigger than 0, or and not less than 0. Right? In a sentence, that user number is a sentence is for another human, an intelligent creature that can infer that's what we're talking about. The machine cannot do that inference. So hopefully that makes sense on how to do the more complicated situations and kind of clean things up. The cleaning up will show a lot more in the flowcharts, because that's the great big picture is going to get smaller. Does anybody have any questions about this before we look at a particular example here?
No, that makes sense.
Okay, so I'm going to grab all of this and cut that. Oh, well, I have to save. And I'm going to put that in another subchart. No spaces. I know better than that. And I'll move that stuff over here out of the way. We saw that, kind of moved our stuff over. That relates to the next set of notes, which I thought we were going to get to today, but I may have misjudged time a little bit because it's already after 3. So I'm going to look at a particular example that some of y'all might need on your final projects, which would apply in Python, but we're not going to look at graphics in Python. It's a little more complicated there. We have to spell things out more directly. This has been up here for a minute, so I'm going to go ahead and erase this. So the logic applies the same when you're doing graphics in any of the programming languages, but since that's also graphics are sort of an extra thing thrown on there, they weren't on that list of major course learning objectives, but I always like to include them because I think it's a useful thing to work with when learning to program. It's easy to see the results, and in our modern world, people don't want to work with consoles. I remember being a computer person back when graphics kind of took over and thought I was done working with the console, working in consoles. So I would much rather do stuff on graphics. So one of the things that you're probably going to want to do, several of y'all have mentioned doing graphics for your final project. You might have maybe a couple pictures of things on there that the user can choose between. Like, choose one of these, and they're going to make that choice by clicking the little button, right? Then we'll provide them a little button. choose either this or that. And the user's gonna come in with their mouse and click on one of those buttons. But that's just a picture on the screen, right? What we call a button is just a rectangle drawn on the screen. So we need to know when we actually click on that button. Oh yeah, I forgot to show Raptor. Raptor also uses those ampersands and pipe symbols and exclamation marks like I wrote on the board earlier. But especially starting out, a lot of people like to work with the words. So you can use both of them. I'll use the symbols on the next one to show that it does work. So we need to know when we click on a button. I'm going to run out of room because I drew that really big. So I'm going to erase the inside of this. That was just sort of an example, but you might have somewhere on some of y'all's final projects that involve graphics, you might have something you want users to click on, like an exit button. We've already seen enough to draw that box on the screen and click that button that says exit so we know we're done with it. That'll probably make a good example. So we saw in Raptor over here's pixel 0, 0. And to define a rectangle, we just need 2 points. Right. We have x1, y1. And then an opposing corner of that, whether we go this way or this way, a corner diagonally tells us how wide the rectangle is and how tall it is. So 2 points give us that information. So when we want to click on a button, we kind of have to narrow that down. I have a couple colors here. I'm gonna try to do it with colors. So we have to narrow it down in every direction. So we need one of these compound conditions to check. First off, if the user clicks over here, that's no good. So the first thing is we know we have to be past this edge of the button. So that was our x1 value. So the first thing to tell whenever we do a click, we'll get the mouse click, and the computer's automatically going to give us that in some place called mouse X and mouse Y. We'll see that here in a second. That part's built in. But we want to know where that is. So the first thing we have to check is if our mouse X, which here on the board, I'm going to abbreviate that as MX and MY. In the program, we actually want to spell it out and be descriptive, but it's a lot easier to type than write. So we can do longer words when typing. So we'll have those based off the click. The computer's going to handle that for us. And first thing to determine if we click the exit button is we have to be to the right of that X1 line, which would be a straight line. So if our MX is bigger than X1, that tells us something. That tells us, narrows down anything over here. But we need multiple conditions. Because clicking way over here wouldn't be any good, right? Our picture of a button's over here, so if the user clicks here, that's definitely not the exit button. So we need that and condition. So our mouse click has to be bigger than X1, and the mouse click has to be smaller than X2. The X2 would be this line over here. So when we put those conditions together, it narrows it down to just that narrow width. But we're still having the situations where we can click above or below, which would be our Y values. And we have to do it in separate segments so we can narrow down to like everything above the bottom of our button. again with another and our mouse Y is bigger than our Y1 value for the picture I drew here. We can define those differently. But we still need one more here. I guess I'm out of colors. I only have 3 colors in here. I'll use white. That Y2 value by itself produces another line that goes all the way across our graphics. So again, that's just a number, so we can check less than that number to get everything down. And if you follow through those arrows that are marked to the right of the blue line, to the left of the green line, above the red line and smaller than the white line, the only thing left that fits all of those criteria is where that button was drawn. So to click a button, the mouse Y also has to be smaller than Y too. We need a big complex situation like this. One of these big compound conditions combined with an and, because we need all 4 of them to be true in order to know for certain that we clicked on a button. So I wanted to do that for our example in the flow chart of that. I think the graphics can be helpful for learning this stuff, is the reason why I like to look at these. Plus, most of us want to have nicer looking input than the console. So we saw this before. We can call some pre-built code, things that are already made for us. All we have to do is ask for them, such as open graph window, and give it some sort of size. I don't know, 500 by 500 is probably good. Or 550, since I made a typo there. And then once it's there, we could draw a box on it. That's something we saw before, right? Draw a box. And we need those 2 coordinates. So maybe we'll come 200 pixels over and 45 pixels up. And then we'll go another 120 pixels over. So 320 over, or 321 over. So 121 pixels further over. And another 90 pixels up will probably work. And make that a red button. And yes, fill it in. So that'll give us that little box there. Then we saw how to write words. So display text. We'll go somewhere near our button. So it looks like it's on our button, and drawing that afterwards so it draws on top of our button. So we start 200 over, so we'll come a little further than that, maybe 220. And somewhere between 45 and 90. So I'll put in maybe 60, see what it looks like. And write the word exit in white. That works. That gets us our picture, right? We have a bunch of stuff going on up here, and when the user's done, we want them to be able to click and leave and shut down the program.
It's not working.
Oh, well, we haven't done all of it yet.
Okay,
Did you get the picture to draw?
I got it.
Okay.
Got it.
Yeah, all we've done is drawn a picture. We need to catch those mouse clicks, which that is something that's pre-built for us.
Yep.
Again, Raptor was built before, or yeah, Raptor was made before the internet really took off. So all of the stuff is over here in graphics. We have mouse operations. So the help menu is built in instead of being on a website. So we have these things: get mouse button, get the X, get the Y. It gives us these values, and we can assort it, assign it. I have this wait thing. This is a useful one. Wait for mouse button and which button So we want to kind of pause along the way. And then we'll call this function that will just pause for a moment. That wait for mouse button. Oh, wait for, oh, and you'll notice there in the predictive text, there's also a wait for key. So that would work exactly the same. There's just a lot more things we have to check, right? Like check, was it an A key or an S key or a D key or a W key, or the space bar or the shift are probably the ones.
Or arrow keys for movement, maybe.
Yes. Well, I was thinking the WASD, but yeah, the
Okay.
arrows, which are up, down, left, and right. But we have to actually, we have a whole bunch of things to check there. With the mouse, there's just a couple of them. And there's pre-built left button, right button. To start with, probably just, you're gonna do just simple mouse clicks, left button, right button. Don't need scrolls or anything.
Yeah,
So
probably.
we draw our box and then nothing happens until we do a click. And then once that click happens, like that's just a delay, then we can grab our X and Y coordinates. So I'll put that somewhere called mouse X and call this get mouse X function. So once a click happens, because we're just waiting and waiting and waiting, we'll grab the X coordinate from that and put that into this variable. And same thing for our Y. Mouse Y is get mouse Y. Again, things that are already pre-built ready for us that will relate to the next lecture, which will be Wednesday, I suppose. And then we can make a selection to see what happened. In this case, the thing that was written on the board. We have our picture of a button. I might have to zoom out a little so I can see those numbers. Okay, there we go. So our picture of a button indicates we're only worried about this area right here, from the point 245 over to the pixel 321.90. That defines a little rectangle, and we only care if the user clicked on that rectangle. So we have to do that, narrow down from each of those XY coordinates to see if we're in that range. So which the if is built into the diamond shape. So if our mouse X click is bigger than the bottom of our rectangle, which is the lowest, or sorry, X, then the left-hand side of our rectangle. So the smallest X is 200. So we need to be bigger than 200. And which we can do with two ampersands. You can use the word or the ampersands. And then two pipe symbols means or, and an exclamation mark means not, if you would prefer to use the symbols. More languages use the symbols than the words, but there's not a shortage either way. So you kind of want to get used to both of them, really. But most people starting out think the words are a little easier to work with. So if you're following along, you could just write the word and there, if that helps to make more sense. So our mouse X is bigger than 200. We don't want to say click at 400 pixels over, because that would be past our picture of a button. So we need to explicitly restrict that on the other side, and mouse X is less than 321, which obviously in a more complex, in a more built out scenario like your projects would be, you'd probably have those numbers stored in variables somewhere, right? Not necessarily hard coding them in, because if we need to change it, we'd have to go back and change every one of those spots. But if we store it in a variable first, as far as like rectangle position, rectangle corner 1 and rectangle corner 2 or something, then we can just refer to that and only have to change it one spot. So that narrows us down to that nice little vertical range instead of our whole rectangle. And we have to do the same thing horizontally. Oh, I was using symbols. And our mouse Y is bigger than our smallest Y coordinate, which was 45 here. It's bigger than 45. And mouse Y is smaller than our biggest Y coordinate, which was a 90. This is an exit button, so over on the yes side, I'll just close the graph window. And on the right side, I'll just, I don't know, I'll print out a message to the console. That was the wrong spot to click. In this case, we get to the end either way. We haven't got to loops yet. We'll get to loops after the break on Wednesday, I suppose. And then we can keep going and check more than one click. But for now, we haven't got there, so there's kind of one or the other. So it opens up and we have just a picture of a button. That's all our graphics are. And if I click there inside that picture, it should shut it down. It takes this route through the flow chart and shuts down gracefully. It's happened really quick, so add this clear console. That way we can see that message pop up. So if it goes slower, goes through all our steps, opens the graph window. And you can see once it got here, it's just going to sit here and wait forever. A machine will wait forever. It doesn't mind. It will repeat things forever. It'll just sit there for however long we're waiting. If I click somewhere over here, right up in the big white spot, there's no picture of a button there. It moves forward. It was not in that range, so we get that bad output. Maybe I should just print some stuff. Print mouse X plus a comma plus mouse Y. So we can see where the spot that was clicked is. Then print out that was the exit button. And shut down the window gracefully, or just print out that other message. I popped up in a better spot that time. So if I click over here in the white, see 196.311 does not meet that condition. Mouse X greater than 200. So right off the bat, it failed. If we use the bitwise operations, it would have to compare every single one. It runs no matter what. But when we use the full just regular and ors, once it knows it's true, it doesn't need to check any further. So our first condition was false, so it didn't need to check anything else after that. The 311 would have been okay. Smaller than, oh wait, no, it wouldn't. That's the Y. Both of those would have failed that condition. Or click on the button, sit there and wait, and we click somewhere in that range. 264.66 is bigger than 200 and smaller than 321. And 66 is between 45 and 90. So you can see the buttons all we have with the button is just a picture of a button. So we have to manually use our logical operators to build up a condition to check whether or not that's the particular one we need. Does that make sense? Anybody have any questions about that?
No, that makes sense.
And similar thing for a key. Why don't I do a simple key press? So if we did not click the button, then maybe alternatively we can click the X button. We'll call wait for key. And then once we get that key, say key to get key. And actually we want get key string. Get key will give us the ASCII code for that symbol. So if you're waiting on a special symbol, the ASCII code might be useful. Right, we saw that earlier. I think it was like in last week's assignment. There was a quiz or homework thing over it. So if we didn't click the exit button, then we can grab a key and do the same check. I'll just do a simple one here. Just use X. So if key is equal to an X, well, then we want to exit. Oops. I'll kind of repeat that. That was the wrong key to press. So if any other key will say it's wrong, that was the exit keyboard shortcut. So obviously our keyboard shortcuts, we might want a complex situation, right? Like we might want it to be Control X or Shift X. So that way it's not something as likely to happen on accident.
Do you write out shift then for it to know it's a shift? Okay, and then you just add the strings together and it'll do both.
Yes. So if key is, so we grab multiple keys. That one actually we'd have to wait on arrays to get multiple keys. But when we have multiple keys, then we'd have an array. We'd have a collection of the key presses that happened. And
Is that what happens in command line whenever you're not inputting anything, but it's showing a raised symbol, kind of? Yeah.
Yes.
Yeah. Okay. Yeah.
It's this. If you have, that's something. If I'm understanding you correctly, that's something that's usually off by default, but you can activate it so that you can see everything the computer's doing.
Yes, it shows your input. Yeah.
Yeah. So it shows. Yeah, it's showing all the stuff that the computer knows about. So, well, first off, I'll click the exit button. We'll see that still works. Let me turn up the speed. If I click somewhere else, see it paused in that wait for key area. Well, I'll push X. So I push the X key. Maybe I should have done that slower. Let me turn that speed back down. Turn that again. Click somewhere, gets us over here. Which the focus moved over to the console, so I have to come back over here and click on that window to bring focus back to this. And now if I push G, I'll just push a different key, push G. Why did it pause? Okay, yeah, so we can see not the right key. So that selection structure is how we work through all those. Those multiple key presses are a little bit complicated. So for your final projects, if you want to do a keyboard shortcut, just make it a single key. That'll be fine. It can be improved later, but there is a slight complication in there that that might be a little beyond the scope of a introduction to this stuff class. If you're already familiar with programming, you probably already know what the little complication would be. And now if I push X, oh, actually, notice how it paused again. Those two things work together. So I don't think we have to wait for key. Oh, stop that, right? Stop. I'm gonna delete that, and just the get key string automatically has a weight implied in it, I believe. Let me confirm that. Okay, yeah, so it's when we say get key string, it's going to sit there and wait for a key to be pressed. Or really, you would do multiple key presses and make sure one of them shift and one of them's X. I guess that's what it comes down to. But that's something a couple of y'all had ideas that we're going to relate to GUIs. And I'm a big fan of learning to program with graphics. We get that visual representation when we draw pictures. See the things that happen first get drawn, or things that happen later get drawn on top of the stuff we drew earlier. We have nice examples for our compound conditions, the more complicated things that we need ands and ors to build up and check. So we can have a couple key presses. If key is X or key is E, make both of them an exit. So if either one of those happened, we'd be ready to exit. That's the basic idea on it. And when you do graphics in Python, the logic follows suit, but the actual doing the graphics are more complicated there. There's a whole lot more to doing the graphics in Python. But the logic, once you have the picture of a rectangle drawn, then it's a very similar thing. Does anybody have any questions about that? Or any of the stuff from today?
No, none here.
Okay, so that leaves us an hour and 20 minutes on our scheduled time. As always, this is an active subject we learn by doing. So now is a great time to do stuff and get some practice at this, try making up situations, or I believe there's some homework, but please use our time productively. For the next hour and 20 minutes, I will be sitting here by the computer. The two fastest ways to get a hold of me are text messages and Ivy Learn messages. Those are the only two things that make noise on my phone. And I'll be sitting here in case you do have any questions. Please use our time productively for your study of IT stuff. Obviously, questions about this class have to come first, but I am capable of answering questions from some of your other classes as well, if that's what you need to work on this afternoon. But use our time productively. And if there's no questions, on Wednesday, we'll get into functions and methods and just modularizing our code, which will go really, really quick. And then we'll go over loops, which will cover all of our 4 constructs that we need to write any program. So I guess that's it for today. I will see you all on Wednesday. You have a great afternoon.
All right, I'll see you. Also,
Bye.
we'll be at Tech Club. If anybody else wants to come join us, you're more than